Okay. Oh, one more. So for bell work today, the code is YWHXFL. You need to solve this for X. I'll give you 3 minutes to try it on your own, and then we'll go over it. Okay. Let's go over this. So, one more person in. The update attendance real quick. So when you're solving these equations, remember the goal is to get x by itself. And just like back in algebra 1, if you wanted to solve an equation for x, the first goal is to get all of your x's onto one side of the equation. So it doesn't really matter which one you move, the sine squared or the 2 sine x. I'm going to go ahead and move the 2 sine x over to the left side. So if I subtract 2 sine of x from both sides, note that those are not like terms because one is a sine squared and one isn't. So the next line would be sine squared x minus 2 sine of x equals 0. All right, the next step is to notice that both of these terms have a sign of x. They have a common factor. So if you factor that out, you'll have sine of x times sine of x minus 2. And as always, it's a good idea to check whenever you factor that you did it correctly. If I was to distribute this side of x back through the parentheses, you would see that I would get the previous line. Side times side would be side squared, and side times -2 is -2 side. All right, now there's another one. Okay. Now that this is factored, that this is what we ended class with last time. You want to set each of these factors equal to 0. So we'll have sine of x is 0 and sine of x minus 2 is 0. The idea being, again, if either of these values could be 0, that it doesn't matter what the other factor would be. Anything multiplied by 0 is 0. To solve this one for x, we just need to take the side inverse. And what is the sine inverse of 0? That's right. And what else? So 0 is an answer, and and 180 degrees. That's the other one. Or if we were doing this in radians, that would be 0 and pi. Right? Remember, sine of any angle on the unit circle tells you the y value, and the y value is 0 at 0 and at pi. Okay. To solve this one, add 2 to both sides. Side of x equals 2. X would then be the side inverse of 2. And what is the side inverse of 2, or the inverse side of 2? Where on the unit circle do we have a y value of 2? That's none, right? Good job. That does not exist. The range, remember, is -1 to 1. So this is undefined. The largest y value on the unit circle is 1. Therefore, the sine inverse of 2 doesn't exist. All right, so we could write our answer then as x equals 0 plus 360 degrees N, and x equals 180 plus 360 degrees N, where N is an integer. But there is an even easier way to write this answer, right? I could just say that this is x equals 0 plus 180 degrees N, right? Because every 180 degrees is when we will have a y value of 0. Or if we did this in radians, that would be x equals 0 plus pi n. Okay, but if at the end of the day, you look at all this and you're lost, don't forget that there is an easier way to do this. You can get this answer relatively quickly. All you have to do is grab your graphic calculator, type in the left side, sine squared x, and the right side, 2 sine of x, and see where they intersect. And you can see they intersect at 0, and then every pi radians. All right, any questions on the bell work? Or does anyone need more time to write? Okay, well, today we're going to finish 5.3, which is dealing with trig equations in quadratic type, multiple angles, and then, I don't know, we won't really need to cover C. C we've been actually using all along. Inverse trig functions. All right, so let's start off with quadratic type. So for example, if we needed to solve this equation, 2 sine squared minus sine of x minus 1 equals 0, you should notice that this trig equation is written in quadratic type. It is a trinomial. It has 3 terms. One of those terms is a function of x squared, and one of those terms is just a function of x. And then the last term is a constant. So this has the form of ax squared plus bx plus c. And as a result of that, you could solve this equation the same way you would do in algebra 1 and algebra 2. You could factor it, you could use a quadratic formula, or you can graph it and find its x-intercepts. There is one catch if you're using the quadratic formula. Since it's a sine of x instead of just x, the quadratic formula is sine of x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And then you'll have to take the sine inverse of that. But to be honest, the easiest way to deal with this one is really just to factor it. And that's going to be true of most of the quadratic types. In fact, I think all of the quadratic types they give you are factorable. So if I wanted to factor this trinomial, my lead term will have to be 2 sine of x and sine of x. That way I get 2 sine of x times sine of x is 2 sine squared. For my second term, the factors of -1 are only -1 and 1. So really the easiest way to factor this is just to plug in and see if that works. And if this doesn't work, switch the last terms. So let's see, does this work? 2 sine times sine is 2 sine squared. 2 sine times 1 would be positive 2 sine. But this would be negative sine. So 2 minus 1 would be positive 1, which is not right. Our middle term should be -1 sine. So does everyone see how this doesn't work? This would factor into 2 sine, or would distribute to 2 sine squared plus 2 sine minus sine minus 1. And then this would be positive 1, not -1. So since this factoring doesn't work, again, the only other option is to switch these two and see if that works. If we switch those, then we get -2 plus 1 minus 1. And now -2 plus 1 is -1. So this is correctly factored. Don't forget that another way you could factor this is to do the, what's the method called? The a squared method? Is that what it's called? Yeah, the AC method. That's what it is. Yeah, not a squared. AC method. That'll work. But to be honest, if with numbers this small, it's almost always faster just to guess and check, because there's like only 2 possible choices and it's easy to check those really fast. All right, now that this is factored, solving this is just like we did for the bell work. We're going to set each factor equal to 0. And then we're going to solve each factor for x. So over here, that'd be -1 divided by 2. Take the inverse. So where on the unit circle do we have, again, I just realized I think I've done too many examples with sine in it. I should switch that up. But where on the unit circle do we have y values of -1/2? Well, right here. And, yep, that's right, and right here. So in radians, then our answer will be 7 pi over 6 and 11 pi over 6. And do note, it's very subtle, but do note your answer for this problem does have to be in radians because of how they define the interval. Since they define the interval from 0 to 2 pi, that is in radians, and therefore our answer has to be in radians. Also note that since we're only doing the interval from 0 to 2 pi, we don't need to put the plus 2 pi n after each of these answers. These answers are done. And now we can go and do our second equation, add 1, sine inverse, and where on the unit circle do we have a y value of 1? Well, hopefully you don't need the unit circle to look that up, right? 1 is the maximum. That would happen at 90 degrees or pi over 2 radians. So my answers between 0 to 2 pi are pi over 2, 7 pi over 6, and 11 pi over 6. But again, if at any point in this problem you said, Mr. Lake, why did I ever take pre-calculus? What is going on this screen? Don't forget, there's an easier way to do this. I mean, it's ideally you would know how to do it this way. That's the goal. We're just taking your algebra skills with quadratic equations and really just adding a new last step at the end where we do an inverse trig. That's really it. And in fact, well, I'll show. Let's show you how to check this really quick, and then I'll show you. All right, left side of the equation is 2 sine squared minus sine x. 2 sine squared x minus sine x minus 1. And the other equation is just 0. And you can see between 0 and 2 pi, 3 answers. Boom, boom, boom. Okay. And again, if all that's really messing you up is the trig part of this, if that's intimidating, you could make this problem a little bit easier if at the beginning you say u equals sine of x and substitute that to get 2u squared minus u minus 1. And then do all your quadratic stuff on this equation, right? Factor it, use your quadratic formula, whatever at the end. And then once you have your answers at the final end, which in this case would have been negative a half and 1, just substitute back. When you have u equals negative a half and u equals 1 as your final parts, then put sine of x back in your problem. And then you'll end up at this line right here. Or if you're doing the quadratic formula, this right here. And then the only pre-calc stuff you have to do is looking up the answers on the unit circle. I might try that technique for the next problem, just to show you it. All right, any questions about this? Does anyone need more time to write? Okay, your turn then. solve this one. And you know what? I'm going to do an audible right now. Okay, you ready for this? I'm fixing my mistake. Replace sine with cosine. So we're going to do 2 cosine squared minus 3 cosine plus 1. I'm tired of sine. I've exhausted it. It's too much. Let's do cosine. All right, I'll give you 3 minutes to try this on your own, and then we'll go over it. Okay. Okay. Looks like from our answers, we're kind of on the right track. So again, we want to factor this, and I'm going to go ahead and show you that u substitution method. So at the very beginning of this problem, let's let u be cosine of x. Then this problem would become 2u squared minus 3u plus 1 equals 0. And again, this is probably easiest to solve by factoring. And to be honest, there's only one possible way this could be factored. The only factors of 2u are 2u and 1u, and the only factors of 1 are 1 and 1. So the only possible way this could be factored, or sorry, I'm lying to you, or negative 1 and 1. And the only actual one of those that work will be the negative one. right? If you try the positive ones, 2u times 1 would be 2u, and then this would be 1u, and if you add those, that would be positive 3u. So again, this won't work. So the only one that works is if these are negative. Right, then if you factored this out or distributed this out, 2u times u would be 2u squared. That's great. 2u times negative 1 would be negative 2u. Negative 1 times u would be negative 1u. And negative 2 minus 1 is negative 3. And then negative 1 times negative 1 is positive 1. Now that this is factored, we set each factor equal to 0. If you solve this one for u, you would get u equals 1 over 2. If you solve this one for u, you get u equals 1. And then, okay, so after you now have this solved with all your algebra skills, right? Now we're going to substitute back. That means the cosine of x is a half, and the cosine of x is 1. And then we just do our inverses. And because we're doing cosine this time, we're asking where on the unit circle is x a half? Because cosine tells us the x values on the unit circle. So you could see x is a half at 2 spots. Here at pi over 3. And here at 5 pi over 3. And the other one, where is cosine equal to 1? There's only one spot where x is 1. Here at 0. So my three answers are 0, pi over 3, and 5 pi over 3. And again, you can verify your answer in the calculator really quick. If we type in 2 cosine minus 3 cosine plus 1, see that that is equal to 0. Here, here, here. And again, that 2 pi is not in the interval. Right, since it's a parentheses, 2 pi is not included. It's only the values less than 2 pi and greater than or equal to 0. So my three solutions are 0, pi over 3, and 5 pi over 3. All right, questions about this problem? Okay, okay. Let's try this one. So the issue with this problem right here is you have trig functions that are not the same type. You have a cosine and a sine. That is going to be a problem. We will not be able to get x by itself when we have trig functions of different kinds. So the first thing we will need to do is to get all of our trig functions to be of the same type. And the only relationship we have between sine and cosine are the cofunction identities and the Pythagorean identity. I can't really use the cofunction identities to make these the same because neither of them have a pi over 2. But I could use the Pythagorean identity if I square this entire function to start with. If I do that, then I would get cosine of x plus 1 times cosine of x plus 1 equals sine squared x. And if I solve this for sine squared, then we know sine squared u would be 1 minus cosine squared. And so instead of sine squared here, I can rewrite my problem in terms of just cosine. If I go ahead and simplify the left side of this as well and distribute, cosine times cosine is cosine squared. Cosine times 1 is cosine. 1 times cosine is cosine. 1 times 1 is 1. Okay. So I will say again what you have to do when you see a problem like this. When you have a homework quiz or test question that asks you to solve it when that trig expression has both cosine and sine in it, 9 times out of 10, you won't be able to use the cofunction identity, and you will have to use the Pythagorean identity to get everything in terms of cosine or to get everything in terms of sine. And in order to use this Pythagorean identity, I need a trig function squared, which we can get by squaring this entire equation. Same, you would be in a similar situation when you have tangent and secant and cotangent and cosecant. If it's a mix other than those pairs, then you will be able, I think, to get it in terms of one function a little bit more easily by using like your reciprocal identities and your quotient identities. And so you should just be ready if you have a problem that has different trig functions in it. The first thing that you have to do is use your identities to get them all in terms of one trig function. And then once you do have that, then this is just solving it like normal. I'm going to get everything onto one side. So minus 1 plus cosine squared plus cosine squared. So I'll get 2 cosine squared. Cosine plus cosine is 2 cosine. And then nice for us, 1 minus 1 is 0. Because this is just a binomial, it only has two terms. I can solve it by factoring. Notice that each term has two cosine in it. So if I factor out two cosine, what I'll have left is cosine plus 1. And then we're going to set each factor equal to 0. So 2 cosine equals 0. Cosine plus 1 equals 0. Cosine 0. X equals cosine inverse. And where on the unit circle is the inverse of cosine 0? Yep, that's right. R in radians, pi over 2, and 3 pi over 2. Again, cosine of an angle, it gives us the x value on the unit circle, and x is 0 at pi over 2 and at 3 pi over 2. Over here, solve this one. -1, cosine of x equals -1 to the cosine inverse, -1. Where on the unit circle is cosine inverse of -1? And yep, that is at 180 degrees or pi. So that our answers are pi over 2, 3 pi over 2, and pi. All right, as you can see, these problems are steadily increasing in difficulty every single time. But hopefully you know what I'm about to say. If you didn't follow how to do this problem and you're completely lost, you could still get the answer, and you could get the answer in less than 30 seconds. We're just going to type the left in, cosine of x plus 1. We're going to type the right side, sine of x. And you see that these two functions intersect at pi over 2, pi. And oh, did I write 3 pi over 2? I think I did. Did I write that correctly? I did. I wrote 3 pi over 2. Sorry. 5 pi over 2. Wait. That's fishy. Oh, it's not fishy. Oh, Mr. Lake, you goofball. Oh, yes. Okay. Sorry. I forgot something. This is great. Oh, I'm so happy. I messed up. Okay. That's great. It illustrates a very important point. Gosh. All right. This answer right here is an extraneous solution. It is not a real answer. Whenever you square something to solve an equation, it is possible that you will create an extraneous solution. So you actually absolutely do need to check these answers. If we plug in 3 pi over 2 back into our problem, you will see that cosine of 3 pi over 2 on the unit circle is 0. But sine of 3 pi over 2 on the unit circle is -1, right? That's the lowest y value, -1. And 1 does not equal -1. That's not true. But when we squared these, it took that answer of -1 and made it a +1, right? And 1 does equal +1. So when we squared these at the very beginning, we created this extra solution because we squared this negative answer and made it a positive, which then matched. So this answer is not real. It is extraneous. The only actual solutions are pi/2 and pi. And we did those before. If you remember way back, and I think it was chapter 3 when we were solving our equations. Whenever you squared an equation to solve it, you had to go back and plug back in. And for us, that was an issue with radicals because you could get an answer that was negative, but when you plug it back into the radical, you can't square root a negative. So those were extraneous solutions. Similar issue happens every single time you square an entire equation to solve it. You might get extra answers that are not actually real. Okay, questions about this? Or does anyone need more time to write? The sun is super bright behind me right now. And so I imagine I look like one of those people on like those true crime shows that is being interviewed, but they don't want people to know their face, right? So it's like all blacked out or whatever. That's Mr. Lake right now. Yes. Okay. Let's see. Oh gosh. Oh no. That's really disappointing. I really want to do this example. We have 4 minutes. And this is an important example. Ugh. Okay, here's what we're going to do. I'm going to extend the homework. So the homework is not going to be due till Friday instead of tomorrow because I do want to talk about multiple angles. That messes up our days a little bit. But I don't think too much. Okay. All right. So no homework due tomorrow. The next homework is going to be due Friday. I'll go ahead and fix that and WebAssign and all that. So with these 2 minutes left, do I have any questions about anything we did today? Okay. Well, then you can head off to your second hour and I'll see you all tomorrow.